All right, year 11. I'm going to go back and do some of these questions from 411. Someone has asked about them. Remember, 411 is all about the discriminant. And I just rewatched the video that I made, the YouTube clip I made. I kept calling this a quadratic equation. It's a quadratic formula we're using, not the quadratic. The quadratic equation is just the solving what we're using. So we're using the quadratic formula. Now, if you remember, the quadratic formula looks like this. So when you have a quadratic equation, so y equals ax squared plus bx plus c, and you want to find where the x-intercepts are, or we also call them the roots, the x-intercepts, or the roots. You let y equal 0. And we know that we can solve that by factorising, or we can solve it by completing the square. And the quadratic formula is just completing the square. So when we, right. So if we put our quadratic equation equal to 0, and remember that the coefficient of x squared is a, the coefficient of x is b, and the constant is c. And when we do the completing the square and with the general form of the quadratic equation, we get the quadratic formula, which is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now you will always get two solutions when you solve this. And we have different terms for them. So let's examine them. And I'm only going to examine them from the positive context, but you have to remember that this also could happen in the negative. So here's a parabola that has two real roots. Now, if that happens, two real roots or solutions, if that happens, or for that to happen, this bit under here has to be a number, a real number, a positive number. So for two real roots or two solutions, you have to have a positive number under there. You could have a quadratic equation that just touches. Now, I call that, or it's termed a double root, but this textbook calls it equal because they're the same. Now, for that to happen, the bit underneath the square root sign must equal 0. And finally, you can have a situation where the parabola does not cut the x-axis, which means there are no, and they say no solutions, but I prefer you to say no real solutions. There are solutions, but they're imaginary or unreal roots. Now, we don't want to write b squared minus 4ac all the time or say the word discriminant. So we use this little triangle to denote the discriminant. So if you have two real roots, well, the discriminant has got to be a positive number or equal to 0. For equal roots or a double root, the discriminant just equals 0. And for no real solutions or imaginary or unreal roots, the discriminant has to be a negative number, less than 0. Now, once we know that, we can decide without actually solving the equation whether or not it has real, equal, or unreal roots. So questions 8 to 12, someone asked about those. So I'm going to do those. So let's have a look at question 8. Prove that 3x squared minus x plus 7 is greater than 0 for all real x. So 3x squared minus x plus 7 is greater than 0. Well, they're asking for us to prove that this is going to be one like this here, that it's always above 0, that parabola exists only above the y-axis. So for us to prove that, we just have to show that the discriminant is negative. So for this, for y equals 3x squared minus x plus 7 to always be positive, we used to call them positive definites because they're definitely positive. To always be positive, the discriminant must be less than 0. We can't have any roots. Well, the discriminant here, discriminant is b squared minus 4ac. And what does that equal? Well, negative 1 squared minus 4 times 3 times 7, which is 1 minus 4 times 3 is 12, 12 times 7 is 84, which is negative 83, which is a negative number less than 0. Thus, 3x squared minus x plus 7 will always be greater than 0. Oh, we also have, because we wanted to show that it was positive, we knew it was positive, a also has to be greater than 0, and a equaled 3, which is greater than 0. That means it's positive, right? It's a positive parabola, and the discriminant's less than 0. Okay, that's question 8. Question 9. Show that the line cuts the parabola in 2 points. Okay, so here's question 9. So we've got this parabola, y equals x squared plus 3. And we've got this line, y equals 2x plus 6. Now, to find where they intersect, I have to solve these two simultaneously. So I sub 1 into 2, which means I'm going to put this wherever the y is, so I'm going to put it there. So I get x squared plus 3 equals 2x plus 6. I bring the 2x and the 6 over, I get x squared minus 2x minus 3 equals 0. I minus the 2x and I minus the 6. Now, I could try and solve this and find the solutions and say, there you go, there are the 2 points. But the question didn't say find the 2 points. It just said show that it had 2 solutions, or it touched it twice. Now, if it's going to touch it twice, that means that the discriminant has to be equal to, has to be greater than 0. If it's equal to, it'll only touch it once, it'll be a tangent. So if the discriminant is a positive number, then there are 2 solutions. So it touches it twice. So let's just do that. Let's not solve it. So the discriminant is -2 squared minus 4 times 1 times -3. And what does that equal? Well, -2 squared is 4, minus 4 times 1 times 3 is -12. Well, that's 16. The discriminant equals 16, which is greater than 0. Hence, 2 solutions. Thus, y equals 2x plus 6 cuts y equals x squared plus 3 twice. So you don't have to find them. Righto. Question 10. We've got a little bit of lag here. Come on. There we go. Come on. All right. Show that the line cuts the parabola in 2 points. That's just doing the same thing. You put them equal to each other, you get a quadratic equation. So I'm not going to do that one. You can have a go at that one. Question 11, show that it does not touch. And question 12, show that it's a tangent. So here, in question 10, you're going to put them together and you're going to show that the discriminant is greater than 0. Here, you're going to put them equal to each other, you're going to show the discriminant is a negative number or less than 0. And here, you're going to put them together, put them equal to each other, get a quadratic equation, and show that the discriminant equals 0. You go and have a go at them. If you're having trouble, come back. I'm going to do questions 11 and 12 here. So, all I'm doing is I'm going to solve them simultaneously. I'm going to get a quadratic equation, and I'm going to show the discriminant is less than 0 for question 11 and equal to 0 for question 12. So, here's question 11. What have I got? Y equals -x minus 4 and y equals x squared. I'm going to solve them simultaneously. Call this equation 1, call this equation 2, sub 1 into 2, which means everywhere there's a y, I'm going to put an x minus 4, so minus x minus 4 equals x squared. I'm going to take these two things over the other side, and I change sign, so I get 0 equals x squared minus x plus 4. Now, to show that it doesn't cut it, so for no solutions, oh jeez, come on, come back. The discriminant must be a negative number. So what is the discriminant? -1 squared minus 4 times 1 times 4. What does that equal? 1 minus 16, which is -15, which is less than 0. Thus, no solutions. So no points of intersection. Now the last one, it says show that it's a tangent. Well, if it's a tangent, it touches it once. So when I put these things together, and you can go and have a go at it, when I put these things together, when I solve them simultaneously, I'm just going to look for the discriminant equaling 0. So Question 12. What are my two equations? Show the line y equals 5x minus 2, and x squared plus 3x minus 1. Y equals 5x minus 2 and y equals x squared, was it x squared? Plus 3x minus 1. Plus 3x minus 1. Okay, solve them simultaneously. It's pretty easy. Sub 1 into 2. And you're going to sub this there, which gives you 5x minus 2 equals x squared plus 3x minus 1. You're going to take all these things and bring them over. So you're going to get 0 equals x squared. So if I minus that 5x, I get minus 2x. And if I add that 2, I get plus 1. Now, for one real solution, the discriminant has to equal 0. Well, what is the discriminant? The discriminant is minus 2 all squared minus 4 times 1, which equals 4 minus 4, which equals 0. So, therefore, discriminant equals 0, only one solution. Thus, y equals 5x minus 2 is a tangent to x squared plus y equals, that's messy, come on, y equals x squared plus 3x, what was it, plus 1? Minus 1. So there, questions 8, 10, 11 and 12, or 8, 9, 11 and 12. All right, good luck with those.